Hi everybody, Mr. Klein here. Today I'm going to talk about how you can use a stem plot to describe data. What kind of data do we have here? Let's see. So suppose you took your temperature, that's in degrees Fahrenheit, for 20 straight days. And here, each one of these is the outcome of one of your temperatures. And I'll notice that the smallest value is 96.7. and the largest is 100.8. And we want to find a way to kind of show off how common different temperatures are in that range. What we're going to do is we're going to take each number and we're going to break it up into two components. So the larger component is the 96 part of 96.7, and the smaller component is the 0.7. What we're going to do with those, let's see how I'm doing with drawing a vertical line here, is we're going to create a stem plot. I'm going to call it body temperature. And I'm going to list the main numbers, the numbers that are to the left of the decimal point here on the left side of that line. So 96, 97, 98, 99, quiet dog, and 100. All right, now what you're going to do with the decimal component of the number is you're going to write that on the left side or on the right side, and you're going to stack those up. So for instance, 96.7 becomes 96.7. Check. 97.0 becomes 97.0. 97.1 becomes 97.1. You'll notice that these are going in order. So we've got a second 97.1. So I'll put a second 1 here. And then a 3, a 5, a 6, a 6. Notice that I'm trying to space these out evenly so that visually it will make sense. And 8. And now we're on to the 98s, which are 1, 2, 3. Trying to line these up vertically. 6, 6, 7, 7, 7. And a 9. Finally, we have a 99.0 and a 100.8. So this right here is called a stem plot. Notice that if I didn't let you look at this information up here, at the actual numbers, you wouldn't be able to tell exactly what these represent. So it's really important to include a key. Your key is going to look something like this. Just pick one of the numbers. I usually pick the first one. 96 point, or line 7 represents 96.7 degrees Fahrenheit. Now, I would say that there is a problem with this graph. Do you see the problem with this graph? The problem that I see is that this temperature right here, this 100.8, is kind of suspicious. It's a little sus. It's a lot warmer than all the other temperatures. And I really should be seeing a gap right here to show off how different this observation is from the rest of them. Now, in order to get a graph that looks like that, we're going to need to do something called a split stem plot. All right, so this one right here is a standard. Right next door here, let me show you a split stem. What do you need, kiddo?
I was wondering, Jamila and I were wondering if we could hang out today.
Let's talk about that when I'm done with this, okay? All right, so for the split stem, I'm not going to bother putting the same title on it. What you're going to do is you're going to split the 96 into 96 and star. More on that in a second. 97 star, 98 star, and so on. And then what's going to happen is, let's just pick one. Let's pick this right here. So 96 has two components. The first one right here is going to get 96.0 up to 96.4. And then the star is going to get the rest of the 96s. It's going to get 96.5 up to up to 96.9. All right, so watch what happens when we do this. Now when we split stem, that 96.7, the 7 is going to go right here because that's in the range 96.5 to 96.9. And then if you look at the 97s here, this first bunch is going to go in the first stem, and the second bunch here is going to go in the split. Okay, so anything 4 or below here, anything 5 or above here. Same thing with the 98s. We're going to see a 1, 2, 3, a 6, 6, 7, 7, 7, 9, 99.0, and then that 100.8 is not going to go here. It's not even going to go here because it's 0.8. It's bigger than 5. It's going to go right here. And so the benefit of doing the split stem is that now we can really clearly see the gap. All right, so let's do another stem plot. Sometimes it's called comparative. Sometimes you'll notice that right here it says back to back. That's another thing you can call it. It says we collected 10 height measurements in inches from members of the Bloomfield Hills men's basketball team. Sorry, that got a little cut off. And 10 measurements of members of the Bloomfield Hills men's wrestling team. So you can see here's our basketball team, here's our wrestling team. They are separated this time. We want to compare them using two stem plots that are back to back. Here's how we do this. I'm going to put the basketball team here on the left side, and I'm going to put the wrestling team here on the right side. Wrestling has an L in it. It doesn't matter which team is on what side. And then I'm going to put the stem in the middle. Something like this. Now, before you put those stems in, you need to identify where's the smallest measurement. Oh, there it is. And then where's the largest measurement? There it is. Okay, so this is our min. This is our max. So we're ranging from 59 to 76. I've got two options. I can either go 50, 60, 70, or I can go 50 star, 60 star, 70 star. And that's what I'm going to do. This is kind of an intuitive approach, but in general, you want to have at least 5 different stems here. And the only way I was going to get that was to add the stars. I'm going to do wrestling first. So 59, 62, 64, 67, 68, 69, 70, 70, 71, 71. Hear how I talk that out loud as I draw it out? You should do the same thing. It really helps keep you organized. All right, so wrestling is done. Let's do the basketball team. Now, the weird thing about the left side is everything's going to look backwards. So, for instance, 68 is going to look like this. 68. You need to figure out that that goes there. 70 would go right here. 70. And then another 70. And then a 71. A 72. Another 72. And a 73. Followed by a 75, a 75, and a 76. All right, so there's the comparison of the two teams. The big thing that I see when I look at these is that the center of the wrestling is kind of up here, and the center of the basketball is down here. So on average, our wrestling team members are a little shorter than our basketball team members. One thing that could be tricky about this is talking about the shape. If I asked you to describe the shape of the wrestling team distribution, you would turn your head to the side like that, right? And you would see, all right, as I go from 50 to 60 to 70, it seems like the tail is over here on the left. So this one would be skewed to the left. However, you have to be careful when you do the same thing for the basketball team. So imagine now I turn my head to look at that. It's going to look like it's a little skewed to the right because you see the tail here. But notice that, in fact, the numbers are going backwards. They're going 70, 60, 50. So if everything's backwards, that means the skew is going to be the opposite of what you're accustomed to. So this one, the shape would be skewed left as well. Or in other words, it's easier to see if you look up here. See how it's kind of dense here on the right, and then the tail is with like these fewer numbers on the left. All right, there it is, folks. There is stem plots.